Good morning. In this class, we will study about carbon dioxide system. This is a one component system because we have only pure carbon dioxide, and this resembles, the phase diagram resembles water one component system, water system. Okay. So let us apply the phase rule. Let us apply the phase rule. F equal to C minus P plus 2. You can write all similar to water. With little differences. There are three differences, and we'll see dry ice. What is dry ice? Okay, now let us apply the phase rule. F equal to C minus P plus 2. This is the normal phase rule. We have earlier studied the reduced phase rule, that is different. Please go and watch. This is normal phase rule, and the component is 1 because it is a pure system, and the minimum phase 1. Okay, F equal to, you substitute in the formula 1, 2. Therefore, there are 2 degrees of freedom to describe the system completely. What are the degrees of freedom? The 2 represents pressure and temperature. Remember, the 2 represents pressure and temperature. So, a plot of pressure versus temperature for carbon dioxide system gives phase diagram. First, draw the phase diagram. Then, we will explain. Similar to water. That's all. Okay, now let us draw the phase diagram, and you have this and this. There are 3 phases. As you see, solid phase, there are 3 regions: solid phase, and liquid phase, and gas phase. Okay, there are 3 phases, and there are 3 curves. There are 3 curves similar to water. OA curve is called vaporization curve. Liquid is in equilibrium with the gas. And we can apply the phase rule. F equal to F1, and the phase, there are 2 phases, therefore 1 minus 2 plus 2, 1. Therefore, degree of freedom is equal to 1. This is univariant along the curve. The system is univariant. The equilibrium system is univariant along the curve OA. Okay, next the OB curve. OB curve is the solid gas. Okay, sublimation curve. Solid is converted into gas. Therefore, it is sublimation. What is sublimation? In sublimation, the solid is converted into vapor or gas directly. Okay, therefore, solid is in equilibrium with the gas, and similarly, you can apply the phase rule. F equal to 1, and in the third curve, OC, fusion curve or melting curve. This is fusion curve or melting curve. You can say solid is in equilibrium with the liquid, and similar to water, a triple point. What is a triple point? The 3 curves OA, OB, OC meet at a point called a triple point, and let us apply the phase rule to the point O, triple point, and one component system, and the 3 phases. Therefore, F equal to 0. It is an invariant system. F equal to 0 means it is an invariant system. There is no variable required to define the system. Okay, at triple point, what is the temperature? Minus 57 degrees Celsius, and what is the pressure? 5.2 atmosphere. It is fixed. Okay, now you are at this point, 3 phases are in equilibrium: solid, liquid, gas. Now, if you slightly increase temperature, it will follow the curve. If you increase the temperature, it will follow the stable equilibrium curve. Now, here. Now, when you on increasing the temperature slightly, only 2 phases there. See, liquid and vapor, gas. So, one of the phase disappears. Either you increase the temperature or decrease the temperature or increase the pressure. If you increase the pressure, gas phase disappears. Okay. So what are the, now we have explained the phase diagram of carbon dioxide. Let us now see the differences. There are 3 differences between carbon dioxide system and water system. We will see one by one. The fusion curve, for example, the fusion curve is in water system, it will be tilted towards the p-axis. Remember, the fusion curve or the melting curve is tilted towards the pressure axis. Here is tilted away from the pressure axis. Away. Okay, the fusion curve is tilted away from the pressure axis. Therefore, for example, this is the melting point. Now, increasing pressure increases the melting point. See, it is pressure is increasing. I am increasing the pressure now. I am increasing the pressure. Melting point is increasing. T is increasing. Increase in pressure increases the melting point or freezing point. That is, the volume of liquid is greater than volume of solid carbon dioxide. Whereas in the case of water, if you consider water, the volume of ice is greater than volume of liquid, because on freezing, when it becomes, for example, if you keep water in a bottle, it will break, because the water expands on cooling, becoming ice. Okay, therefore the volume of ice is greater than volume of liquid, but in this case volume of liquid is greater than ds. Therefore dp by dt, according to, you can write all the Clausius-Clapeyron equations similar to here, you can write. So dp by dt is positive in this case, whereas dp by dt is negative, is equal to negative in the case of water system. Okay, remember that they will ask in various competitive examinations. Next, at triple point, the temperature, at triple point it is invariant system, the degree of freedom is 0, temperature is minus 57 degrees Celsius, pressure is 5.2 atmosphere. For water, it is T is equal to minus 0.0075 degrees Celsius, this is nothing but 0 degrees Celsius, and pressure is 4.58 millimeter. That is, this is very, very great. See, 1 atmosphere is equal to 760 millimeters, therefore, this is 5.2 into 760 atmosphere. The pressure is high. The pressure is high for carbon dioxide. The pressure is very high for carbon dioxide at triple point. Here the pressure is very low in water system. The pressure is very low at a triple point. So that is, it melts at very high pressure. Only at high pressure, because carbon dioxide is a gas. If you want to make it liquid, you will have to give high pressure. Only at high pressure it melts. Okay. Next one is the third one is the vapor pressure of solid carbon dioxide. Solid is carbon dioxide is easily it is a gas only. It can be easily converted into gas. Therefore, you have solid carbon dioxide. You have ice, solid ice. Which one will have greater vapor pressure? This is carbon dioxide, because the vapor pressure of solid carbon dioxide is greater than the vapor pressure of water vapor in the ice, above the ice. Even at low temperature, the vapor pressure of solid carbon dioxide is very, very high. Okay, now let us see dry ice. It is a very common question asked in all competitive examination. What is the dry ice? Okay, for example, you take solid carbon dioxide. I am taking solid carbon dioxide. This is ice. After some time, you see this ice, it will become wet. Ice. If you take ice and ice, the solid ice is converted into liquid. It first melts, okay, with the formation of liquid, and your hand gets wet, or your paper gets wet, or cloth gets wet. Whereas in the case of solid carbon dioxide, it is directly converted. It is directly converted into vapor. That is sublimation. Solid is directly converted into, at 1 atmospheric pressure, at room temperature, the solid CO2 is directly converted into vapor without the formation of liquid. Therefore, your hand won't be wet. Therefore, it is called dry ice. Why it is called dry ice? Because of this, at 1 atmospheric pressure, the solid carbon dioxide is directly converted into vapor without the formation of liquid. That is, even it can be expressed in the form of equation. Solid is converted into vapor at 1 atmospheric pressure and minus 78 degrees Celsius. At minus 78, even at minus 78 degrees Celsius itself, it is directly converted into gas. Okay, so they will ask questions based on dry ice, triple point, comparison of water and carbon dioxide system, and what is the degree of freedom along the curve, what is the degree of freedom here, what is the degree of freedom in this one phase. If it is one phase, therefore C1, therefore this here is a plus 2 variables are required to describe the system. Okay, so thank you for watching.